Welcome to today's discussion on defining dynamic TypeScript type or interface key. If you're working with complex data structures in TypeScript, chances are you've encountered situations where you need to define types or interfaces with dynamic keys. Perhaps you're dealing with API responses that have varying key names, or maybe you're creating a library that needs to support flexible configuration options. Understanding how to work with dynamic keys is crucial for maintaining type safety in code, maintainability in such scenarios. In this video, we'll delve into the world of TypeScript types and interfaces, exploring how to define dynamic keys effectively. By the end of this discussion, you'll be equipped with a solid understanding of the concepts and techniques involved. So, let's dive right in. When working with TypeScript, you're likely familiar with defining types and interfaces using the type and interfaces keyword. However, when it comes to dynamic keys, things can get a bit more complicated. To illustrate this, consider an example where we have an API response that contains user data, but the key names vary depending on the endpoint. We might receive responses like ID1, name John, or user id2, full name Jane. In this case, defining a type for this response using traditional methods would be challenging. One approach to tackle this problem is by utilizing the record utility type in TypeScript. The record type allows you to create an object type with dynamic keys. You can specify the key type and value type as parameters, giving you more flexibility when dealing with unknown or variable key names. Another alternative approach involves using the key string syntax to define a type with an index signature. This method tells TypeScript that the type has a string index signature, meaning it can have any string property name. However, keep in mind that this approach might lead to more type errors and less code completion support from your IDE. Let's consider another scenario where we're building a library that accepts configuration options as an object. The keys in this object are dynamic, depending on the specific use case. In such situations, using the partial utility type can be beneficial. By defining the type of the configuration object as partial summa type, you ensure that it's possible to have any subset of properties from some type. To recap, when working with dynamic TypeScript type or interface keys, utilize the record utility type for more flexibility and control over key types. ID type. Consider using the key string syntax for index signatures, but be aware of potential drawbacks. Leverage the partial utility type to allow for any subset of properties in configuration object. That's it for today's discussion on defining dynamic TypeScript type or interface keys. We've explored various techniques and approaches to tackle this common problem. Remember, mastering these concepts will help you write more robust and maintainable code. If you have any questions or need further clarification on any of the topics covered, please don't hesitate to ask in the comments below. Be sure to like this video if you found it helpful, and consider subscribing for more content on TypeScript and software development. Thanks for watching, and we'll catch you in the next video.